GFT have developed an activator that is defined using Terraform, is based on Docker containers, based on a Kubernetes container orchestration framework and Istio service mesh. And by using Terraform, we're able to accelerate the provisioning of consistent environments for developing modern applications. We've also developed a continuous deployment environment using Jenkins, which is also based on Docker and Kubernetes. In the same way, that allows the continuous deployment environment to scale accordingly to load and demand. And that accelerates the provisioning of consistent environments for deploying modern applications. So the combination of having a microservices-based architecture based on Google technologies, combined with a continuous deployment platform that allows you to deliver a change at will and match the business pace of change, I think is really quite compelling. So just before we go into the modern application, I just wanted to show you a little bit of what is behind the application. So we're going to see a demonstration of this application. We're going to show you a canary release of some new functionality, a new small business change to a group of you. And we'll see how that goes, the gods of demos notwithstanding. And then, fingers crossed, we will then promote that change so that everybody gets that new feature. Just to show you how quickly that we can deliver functionality into the production environment, and then once we've tested it, we can then enable it to everybody very quickly. So in order to kind of support this story, we have a fictional company called Blue Canary that has developed a payments transfer application that you should now all have access to. If you don't have access to it, you have a QR code that was on your seat. There's also a tiny URL there to follow. But if anybody doesn't have access to it or is having some issues, then please could you let one of our team know, and we can help you out. Okay? So the application allows people to send each other payments in a given currency, and you should be registered for the application. So all you should really need to do is just log in with your email address. So you'll notice you've been gifted £100 in complimentary credits. But it's non-refundable, right? So, yeah. Okay, so let's have some fun. If you please select and send credits to someone else in the audience, if you haven't already. It doesn't have to be one of your colleagues. You could be someone who you think really needs it. If you're lucky, you should see that someone has sent you some money, and if not, it might be a good time to reevaluate who your friends are. Okay, we have 3 Google Home Minis to give away, just to incentivize you to actually use the application. So, you've got to be in it to win it. So you will see that there are multiple currencies available, and there's no way to see a history of who paid you or who has paid you. And we'll kind of get to that bit in a moment. I just wanted to go over to the architecture and just explain a little bit. I mean, Henry's going to go into a lot more detail from Google, from a lot more detail into the technologies behind this. But essentially, we have our application, both web-based and mobile-based application here through Nginx, and obviously it's based on the Angular framework. We're going through a level 7 HTTPS termination point for cloud load balancing, then on to GKE. So just to be clear, this is based on GKE running on GCP at the moment to really benefit wholly from being on Google technologies. We then go into our environment here where we have some common security. So we want to touch on the fact that we've got security integrated as well. So we're using HashiCorp Vault for automated key management and access control. But frankly, that's another topic entirely. So right now, we'll just address that here in passing. If you want to actually discuss it a lot more later, then please come to the chat stations and we'll be happy to discuss that. So we have a production environment. We have a number of microservices here based on Kubernetes pods. And then we have some persistence based on Cloud SQL, followed by our continuous deployment environment based on Jenkins here. And then we also have, facing off to another part of the business where you talked about APIs, we have an API gateway. Again, for the purposes of this demo, we're not going to touch on the API gateway right now. We're really just going to talk about this, the user interface-based approach, but we have an API gateway here in place that allows you to interact with our application directly through an API, which I think that really kind of touches on what Adrian raised, the prevalence of APIs and how powerful it is to introduce them as a point of measurement and monitoring. So we're running the Canary release pipeline. It's going to take a couple of minutes. However, what it does at the end of it is that it's released something into production. Now, as you touch on what Andrew was talking about before, imagine how long it would take you to get things into production otherwise. So, bear with me. Maybe this is not quite as a regulated environment as you're used to. Yeah, but the principles are that we built pipelines that address your common needs. So the pipeline we have in question is a combination of, we're using ITOP for basically simulating kind of ITIL change management integration. So we can raise an automated change request ticket. We can then build, so check out, build, test, package as a Dockerized image, our code for the microservices alongside with the Istio rules that we then publish onto our environment. So Istio takes on the routing rules and Kubernetes takes on the microservices and Dockerized images. We can then run post verification tests in production against that deployment. And then if everything goes well, we can sign off the change request ticket. If not, we can raise, we can revoke that ticket, we can roll back the deployment, and we can then raise it's not shown here, but we can raise a defect ticket directly in something like Jira. So the pipeline fully automates the deployment end to end from checking out code, building, testing, deploying, post-verification testing, change management. At that point then, the change is in production. So what is this change that we're going to deploy? So based on customer feedback, Sue, who's the product owner at Blue Canary, has identified the need for a new feature, transactions history. So what a coincidence. So we could spend a great deal of time and effort arranging a focus group and inviting those people to formally demo the new feature, as was the way back. Instead, Bob, an engineer at Blue Canary, and his squad have built the new feature such that it can be deployed as a Canary release, a small business change, to a select group of users directly, and to get their feedback immediately. So, as I touched on, we're deploying the Canary release through an automated deployment pipeline. We're using Jenkins. I touched on it. I'm going to mention it. Most of you probably know what Jenkins is, but it's a popular open source CI/CD server. There are others. Spinnaker, for example, being one. And so I think the key here is this, really, as Andrew was touching on, which is the post-verification test. It's this ability to have your code in a way, in a form, in production that is safe. It's isolated from the rest of your production code, from your production system, but you're able to exercise it in the only place that truly matters, the only place that actually looks like where it really will be in the end, which is the production environment. We spend so much time, effort, money on trying to build non-production environments, staging environments, testing environments that look like production, and for lots of reasons they never do. They have part of the componentry that enables you to test one aspect of it, but not all aspects. And so, really it's a cost exercise more than anything else. So if you can reduce those costs by being able to test it in the only place that really matters, first you develop it, then you actually deploy it to production, and then you test it where it's supposed to live. That is so powerful. It removes a lot of the potential stages for you to have a configuration change in any of those environments, the lack of consistency across them. Invariably, when I've been involved in deployment, where we've had even automated configuration change, because we haven't had consistent environments, 95% of most of the problems we had were associated with misconfiguration, a configuration change based on a different environment. And so I think this ability to be able to capture configuration once and have development look like production and then be able to then simply deploy directly from development into production, I think is extremely powerful. So now, who's got the feature? It should be only Deutsche Bank employees. Fantastic. So I'm going to say now only people who identified they work for Deutsche Bank should be able to see and use the transaction history. Okay. Everyone else should still be, there shouldn't be, there was a notification that said, oh, actually I'm spoiling the surprise. Okay, so now if we've identified that the deployment got out there. And you should be able to, by the way, if you click on the transaction history button at the bottom of the application, be able to see what transactions you made. So now we're running the promotion, the canary promotion pipeline. And again, similar kind of stages, but in this case, the code is already there. It's already in production. It's just in an isolated form. We've isolated it using the routing rules that are configured in Istio. So all we really need to do is we really need to release an updated set of routing rules and possibly a Kubernetes configuration change in order to be able to allow it to scale maybe differently or better according to greater load. So to affect the scaling characteristics of Kubernetes. But essentially, we're really just changing the configuration of this piece. We're not touching the code. The code doesn't change. The code is already there. We've run post-verification tests. We are running it, with a select set of users to be able to give us feedback. So I think that is extremely powerful. Most of the time, you keep deploying everything, and it takes so long to get all of that there again in production time and time again. And there's always a possibility that something creeps in afterwards that you then have to go and do a retrospective and find where that bug actually crept in at that point in time and go and fix it. And then, you've got another release to do. So it's kind of release once, test, promote, and keep doing that small cycle. And one of the things that I think is very key here is, and Andrew touched on it from ITIL perspective, is if you keep your changes small enough that they are inconsequential, then the need for a formalized, heavyweight, CIO-led change sign-off process is really kind of averted. There are going to be times potentially where that will happen, but that should be able to reduce those. And and again, on that message of constant small business change, if you do deploy something that's it's small, it's out there, even though it passes the verification test, it's not going to test everything. Through feedback, you find there's a problem. You can roll it back instantly. It's really powerful mechanism. It's that ability to be able to direct change into production quickly, be able to ascertain how well it's working, be able to roll it back quickly, be able to do it again and again and again, as often as you want. But also have a control mechanism that is present, that allows you to audit that entire process. So you can look back. One of the problems you find, again, historically from my experience, is what's on a server. So, for me, it's the classic example was there was a messaging system, latency message busting. And somebody asked, what versions are we using of LBM? And the answer was, go and check on the server to find out. Nobody actually knew whether there was any consistency around what version we were actually using. And so as a result, there's never been any interoperability testing. So it's an accident kind of waiting to happen. And then, of course, the problem is the only time you see the accident typically is traditionally when the business users are telling you there's something wrong with your system, which draws you back into monitoring and continuous monitoring. This idea that you understand how your system is operating, and you understand when it's not operating normally. It's starting to show the signs that maybe queues are starting to back up. Some part of your system isn't responding quite as well to increased load, that there is increased load. And so it's this idea that you can clearly identify ahead of time that there are going to be issues and to remediate them. I think that's one of the key aspects of building not just a microservices architecture, but a pervasive kind of monitoring platform. And so we're done. So now, everybody should have the new feature. Okay. Gods of demo, thank you.